Hello everybody, myself Suresh Naidu, lecturer in Government Polytechnic Ballari. I'll be handling the subject strength of materials for third semester. In this, first chapter is simple stress and strain. Before starting, let me start with a note. In this world, nothing is permanent. But one thing is permanent, that is change. We'll also accept this change and move from classroom teaching to online teaching and make best use of this media. In today's session, we have introduction, type of external loads, stress, type of stress, strain, type of strain. Introduction, as we are engineers and you are budding engineers, you use many material to build a project which are made up of different material, sizes and shapes. For your project to be successful, you should know the strength of the material. Then what is strength of the material? Strength of material is the inherent ability of the material which it possesses to resist the external forces depending upon strength of the material. We have types of external loads or forces. There are n number of loads, but from subject point of view, we will be learning tensile load, compressive load, shear load, bending load and torsional load. Tensile load. When a body is subjected to two pulls as shown in the figure, then it tends to increase its length, which is shown by the dotted line, and it is known as tensile load. Compressive load. When two opposite pushes act on a body, as a result of which the body tends to decrease its length, which is shown by dotted line, then it is known as compressive load. The best example for tensile load is when you lift a weight with the help of a crane, the rope experiences a tensile load, and a rope in a tug of war experiences a tensile load. The example of compressive load, a pillar between ceiling and a foundation, is an example of compressive load. Shear load. When a body is cut across by action of two equal parallel tangential opposite forces, it is called as shear load. The best example is when you cut a paper using a scissor. This is an example of shear load. Bending load. If it is a load applied on a body to bend and make a curvature, this is a beam which is supported at the ends. When you apply a load P, it forms a curvature. Then these kind of loads are known as bending load, torsional loads. The loads applied on a body to twist is called as torsional load. Example, all shafts which are used to transmit power through pulleys, gears, etc. are subjected to torsional load. Stress. Stress is defined as the internal resistance set up in the body due to applied external force per unit cross-section area is called stress, or stress is also defined as force per unit area. Mathematically, as you know, stress is indicated by F. We know that it is load P by cross-section area. That is equal to F is equal to P by A, Newton per mm square. We'll come to know what is internal resistance and how it is set up in the body. Let us consider a square bar and apply tensile loads P. Due to this, what happens? The body expands to a certain limit. Afterwards, it stops. Why it stops? Because the body sets up a resisting force equal to applied load P. That is called internal resistance. This internal resistance is set up is due to intermolecular attraction between the material. Why we have taken load P instead of internal resistance R? To know about that, let us take a bar where it is subjected to two pulls, and when we take a section along x-axis 2, we know that to this applied load a resistance force R is set up on the right side. To be in equilibrium, the applied load P is equal to resistance R. Therefore, for our convenience, we take resting force. Instead of resistance force, we take load applied, which we know. And for calculating other parameters, we take load P. Therefore, stress is equal to applied load P divided by cross-sectional area. Type of stresses: tensile stress, compressive stress, shear stress, thermal stress, and bearing stress. Tensile stress. When a body is subjected to two equal and opposite pushes, as a result of which the body tends to elongate, which is shown by dotted lines, and the stress induced is called tensile stress. Tensile stress is indicated by F, and the P is load and cross-sectional area. If it is a square cross-sectional area, we take if this is breadth, if it is T, we take B into T, the cross-section area. If it is a circular cross-section area, Then we take pi by, the cross section is pi by 4 d square, and the units are Newton per mm square. Compressive stress. When a body is subjected to two equal and opposite pushes as shown in the figure, as a result of which what happens, the body tends to decrease its length. The stress induced is called compressive stress, and we know that stress is applied load by cross-sectional area. Next, shear stress. When a body is subjected to two equal and opposite forces acting on a resisting section, here it is a rivet testing section as shown in figure A, as a result of which it tends to shear off. You can see the rivet has been sheared off. In figure B, the stress induced is called shear stress. The shear stress is equal to, indicated by F suffix x, is equal to shear load by resisting area, that is P by A, Newton per mm square. Bearing stress, when one object presses against another, it is referred to bearing stress. We can see in the figure the bearing stress is at the contact surface. Strain. Strain is nothing but when a body is subjected to pull, what happens? Its length increases to a certain limit. That change in length by original length is known as strain. Type of strains: linear strain, lateral strain, volumetric strain, and shear strain. In linear strain, we have tensile strain and compressive strain. Linear strain. The strain is change in length to original length in the direction of applied load. Now let us consider a bar which is supported at one end and we apply a load P. We observe that the length increases to a certain limit. That is known as linear strain. In this, we have tensile strain and compressive strain. It is the ratio of change in length to original length in the direction of applied load. Compressive strain. It is the ratio of change in length to original length in the direction of applied load, that is delta L by L. It is an unitless quantity because delta L and L are in same units. What is linear strain? Is the strain that is linear strain is the strain or the changes taking the length. The linear strain is change in length to original length in the direction of applied load. Lateral strain. This is very important. The strain which is at right angles or perpendicular to the applied load is known as lateral strain. See, now let us take a bar of length L. When we apply loads P, what happens? It extends to delta L. This when we consider delta L, and this change is in along the direction of the applied load, then we call them as linear strain. But we can also see that when length increases, the breadth and thickness reduces, and these parameters are perpendicular to the applied load. Hence, it is called lateral strain. Here, lateral strain is change in breadth by original breadth is equal to change in thickness by original thickness. Now we have considered a square cross section. If we consider a circular cross section, then what happens? When you apply a load, tensile load P, you can see that its diameter reduces and its length increases. When we consider length, change in length by original length, it is linear strain. When we consider change in diameter, which is diameter is how? Perpendicular to the applied load, then we call it as lateral strain. For lateral strain, we write it as change in diameter by original diameter. Volumetric strain. It is the ratio of change in volume to original volume. These kind of circumstances arise when the volume changes. Example, when a ball is under liquid, the pressure of the liquid acts on all sides, changing the shape, reducing the size, volume size. Therefore, then volumetric strain is given by change in volume by original volume. Shear strain. Shear strain, it is defined as the ratio of lateral displacement between two layers. Let us consider a body which is made up of n number of layers. In that, we will consider two layers, that is A, B, C, D of length L, and apply a force P in this direction. When we apply a force P, what happens? The layers B, C changes from B dash to C dash of distance, of displacement distance L. Then tan theta is given by delta L by L, where theta is very small. We take theta is equal to, we neglect tan and we take theta is equal to delta L by L. Yes, today we came to know about what is strength of material, type of loads, type of stress, strain, and types of strain. Okay, if you have any doubts, you can call me or message me. Thank you.